Hey guys, so this is unit mathematical models. Our objective is to use functions as mathematical models. Okay, so you don't have to write down this slide, but again, our objective is to use mathematical models, use functions as mathematical models. Some things to keep in mind when we're going through these problems is that these are real life problems. You have to be able to understand the problem in order to put them in terms of functions, okay? Really understanding what the question is asking or what the situation is very important. And then once you have really understood that, then it's easier to make a function that represents that situation, okay? So, there's only a couple of examples that we're going to be doing in this video. Really beginning to do well on this topic is about practicing, which we're going to do more of tomorrow or the next time that we meet on Wednesday, okay? So, mathematical model. A mathematical model is a function that is used to describe a real-life situation. Okay? For instance, Ms. Diaz has a budget of 400 kroner a month for lunches. If she forgets to bring a lunch from home, she buys a 25 kroner lunch from the cafe. Write a function that describes the money M Ms. Diaz could save if she buys L lunches at the cafe. Okay? So, some things to highlight. She has a budget of 400 kroner. Okay, that's important to note. And then every time she forgets one, she deducts 25 kroner from her 400. Right, so she's using 400 or 25 of that 400 for her lunch. Now, we're gonna write a function that describes the money I could save if I buy L lunches, okay? So, L is the number of times I pay for 25 kroner, right? So, L is going to be the input. How much money I could save is going to be my output, okay? So, I start out with 400 kroner, right? And every time I have to buy a lunch, I deduct 25 kroner. So let me write that better. 25 kroner for every lunch that I purchase. Okay? Any money that I don't spend of that 500 is money that is saved. Okay? So notice that it gave us the variable for our output. It gave us the variable for our input. Okay? This is the mathematical model that represents my budget for lunch. Okay? So, let's do another example. John and Isaac are Arsenal fans, and they always watch the games together. They buy, they buy pizzas, P, for 150 kroner each, and they get a 2-liter of pop and share it for 50 kroner. Write a model that represents the cost, C, for when they watch a game. Okay, so again, I'm going to go through and highlight things that I need to have, right? So, P is the number of pizzas they buy, and each of them are 150 kroner. They also get a 2-liter of pop, but do I need that too? No. What I care about is how much it costs, right? So, the 2-liter of pop is 50 kroner, and they only get one because they share it between them. Okay? We're going to write a model that represents the cost. So the cost is my output. Okay? Now, what happens every time they buy, or every time they watch an Arsenal game? They at least share one 2-liter of pop. So that's 50 kroner. at least they buy one pop and they always share that. They don't get multiple of them. Okay? Now, they get one pop, but then the cost is in addition to however many pizzas they buy, right? So the number of pizzas they buy is multiplied by 150. Okay? This is the mathematical model that represents John and Isaac's Arsenal watching games. The cost of that. Okay? So, again, the cost, see, is 50 kroner for the pop and 150 kroner for every pizza. Okay, so this one is in your book. And we're going to go over it together. I added another part of it, though. So, a rectangular piece of card measures 20 centimeters by 10 centimeters. Squares of length x centimeter are cut from each corner. The remaining card is then folded to make an open box. First, we're going to write a function to model the area of the card after the squares are cut. Second, we're going to write a function to model the volume of the box. Okay? So the first thing I'm going to do is I'm going to write a picture make a picture because I don't know what this looks like. So I'm going to make a rectangular piece of card. Okay? It says that it's 20 centimeters by 10 centimeters. So I'm just going to label that 10 by 20. Okay? And then it says squares. So squares of a certain length are taken out. Now, I don't care what length they are, but I know that they're squares. So each side is the same length on a square, right? I don't know if these are perfect. One's a little bit bigger than the other. Oh well. So all I know is that each one is a size of x by x. Okay, so now I've labeled everything. I know that these parts are going to be cut out. Okay, so I want to talk about the first part. It says to write a model for the area. Well, how do I find the area of a rectangle? It's just my area equals length times width. Now, I don't know if you guys use different terminology, but that's just the width and the length. Okay? Sorry, that's kind of sloppy, but that's what it's talking about. You just multiply the two sides by each other. Okay? Now, if I'm looking at this side right here, after I take out the x's, what is that length going to be? Well, this is 1x, and this is another x. So how many x's am I taking away from 10? I'm taking away 2 x's. So area is going to be 10 minus 2x times, same thing on the side with the 20, these has a length of x and x. So I'm going to have 20, and then I'm taking away 2 x's. Okay, because that's the length that this is right here. That's being cut out. This is the model for the area. Okay, now volume. I won't erase it. I'm just going to make it a little smaller. Okay, so let's talk about the volume. The volume of a box is length times width times height. Okay? Now, you have to be good at like imagining, right? So you're cutting out these little squares And then when you fold it up, what is the height going to be? If I'm taking this part out, when I fold it up, it's going to be a height of x. Okay, so my height is going to be x. My length, we've already determined, is, well, it doesn't matter which one it is, but it's 20 minus 2x. And then the width is just 10 minus 2x. Okay? So if I put all of these into, oh, sorry, this isn't supposed to be A, it's supposed to be a V. See, this is what happens when I don't teach you in front of you. I make mistakes because I get in my head. Okay, so the volume is length times width times height. I apologize. Okay, but so all you're going to do is take in H and put it into here. Take in L, put it into here. W into here. So you should get volume equals X times 20 minus 2X times 10 minus 2x. And that is the model for volume. Okay? Now, I know it looks a little complicated, or you might be a little confused, but that's okay. The only way we get better at this is if we practice. Okay? So we're going to be practicing on Wednesday. Make sure that when you come to class on Wednesday that you bring the worksheets from Tuesday and the assignment that we had today, page 144, 1 through 6. Try to get that done. You can always come see me. Remember that I'm in Mr. Dimmon's old office on the first floor. Okay? Have a good evening.